Number 1, the amount of paint, which is our Y here, needed to paint a certain amount of chairs is shown in the table. Is the relationship between the two quantities linear? What does linear mean? Linear. Oh, man. Talked about it yesterday. Linear. Go back and look if you don't remember. Did you know it?
Me?
Yeah.
Why me?
You're not looking back, so I thought maybe you knew it.
What years?
I can look. Linear. I even told you it has the word in it. It's a line. It makes a line. So if I graph these points, we got to decide, is it linear? Now you can do this without even graphing, right? Because on that top half of our notes page yesterday of our vocab, it said linear relationships always have what? Start with C. Constant rate of change. So what are these changing by?
2, 5, 6.
Okay, 5, 10, 15, and up by 6. 6, 12, 8. Is that constant?
Yes.
Yeah, so will it be, is the relationship linear? Yes. Okay. And then you have to explain.
6 over.
It has constant rate of change. Let's get that vocab in there.
So if you don't have this written down, you need to write it down so that you can have the correct answers to reference later.
Okay, now we're going to figure out what that constant rate of change is. Yesterday, you guys just said, oh, it's going up by 6. Oh, it's going up by 5. Well, we're going to think about those in different terms. Yesterday, you had an example of, it was like 2 songs per minute. Okay, or we go miles per hour. We don't typically look at information this way or report it this way. So if I went to the store, or if I was telling DJ I was painting some chairs at home, okay, would I say I need so many cans of paint per chair or chairs per can of paint? Paint per chair, right? My cans per chair. So if I look at this, cans per chair, you can also write it cans, add in words, per chair. What does this remind you of, though, if you use this slash bar? Where do you see that in math?
Division.
A fraction. So if I set this up as a fraction, what am I going to list first? Cans. How many cans of paint do I need? Per chair. How many chairs for that 6 cans? Do we leave fractions like that? No. Let's change it to a mixed number. Oh man, we're going to have to remember back. How do I do that? No, that's multiplying. Yeah, how many whole fractions can I get out of this? So my whole fraction would be like 5 over 5. If I take 1 out, I'm left with one whole thing. 6 minus 5 leaves me 1 left.
Don't have this down. You need to write this down.
So this is your explanation. Yes, it has a constant rate of change, which is 1 1/5 cans per chair. Doesn't sound very 8th grade like if you say, oh, I'm going up by 5 and I go up by 6, okay? Questions on number 1? Going once, going twice, everybody have it? I guess I have it written down here. I can keep writing. All right, number 2, the altitude. What is altitude?
Height.
How height, okay? So you might, like in the mountains, they talk altitude a lot, okay? In this case, we're talking about an airplane. So a certain airplane after a certain number of minutes, so we got our minutes here, our height, or our feet on our y-axis. Is that relationship linear? Does it make a what? A line, okay? Does it make a line?
No.
Okay, no? Anybody disagree?
I disagree with
Anybody unsure? So, yes, linear, no. Not so sure.
that.
Yes, linear, no,
I'm
not so sure.
with my.
Okay, What if I blew your mind and told you it's yes? Okay, and this is how you're going to check. So one, you can do it a couple different ways. If I look at this, it's halfway, right? So if I go down a half over 2, that gets me to my dot, right? Don't write this yet. So what would my next, if it was constant, what would my next step have to be? Down a half, which is really hard to do on this, and over how many? Okay, they don't have one there, but I'm going to just put an X like, yeah, that might be where it is. And then I have to go down half over 2 again. Do I end up where I need to be? Oh. Okay, now wait. It might not always be so clear doing it that way. What if we made a table? X is my what? Time or altitude? X is my what? Time. So if I look at my first point, I have 0. What is my altitude or my Y at 0? 3,500. It's halfway there. My next amount of time is 2 minutes, which is what? 3,000.
Oh my god.
They don't give us 4, but we do have 6, which is at. Okay. What is this decreasing by? 500. So if I kept that pattern, what would this be then? Well, minus 500, which would give me what? Okay. And then if I minus 500 again, does that end me up at 2,000? So is it linear?
Yes.
Yes.
So we were trying to figure out what flow was.
Oops.
Trying to figure out how to constant rate. It's not.
Is the relationship linear? Yes, because it has that constant. All right, now, when we talk constant rate of change, we just got done talking about per minute, per hour. Per hour means how many hours? Or per minute is how many minutes?
1 minute.
1. Is this going by ones? No. So I can't say so many feet in 2 minutes, right? So how do I get it down to that 1? How would I get it down to that per minute if I want feet per minute?
Altitude divided by the time.
Altitude divided by time. Okay, you could. Looking at this, could I do it a different way? Might be a little quicker, less error. So if I have 1 minute here, what's my difference between these two? 500. So yeah, so if I, what's in the middle here then? 250, right? So if this was 250, this would be 3,250. So then I'm going down by how many each minute? 2. Yep, 250. Now, if I drew this line, is it increasing or decreasing?
Decreasing.
Decreasing. So make sure you write negative. Or if you wanted to write that out in words, decrease 250 feet per minute or each minute. Okay? A lot of different ways they can word this. So you got to know that even though they might say something or look just a little different, they mean the same thing. Questions on that? Yep. So really watch, because some of you would have just wrote 500. It's per minute. Got to get it down to that unit measurement. All right, Miss Boston, I'll let you take over here.
All right. Number 3. We have to determine whether a proportional relationship exists between the two quantities. Shows an exercise 1. Explain your reasoning. So yesterday in our notes, we actually did all of those steps. Okay, and the last step was to figure out if it was proportional or not. So open up your notebook to page 38, I believe it was. What was step number 3? How do you figure out if it's proportional or not? Gracie?
You do y1 divided by x1, y2 divided by x2, and then y3 divided by x3.
Okay, so looking at exercise 1, so your very first problem, what was your y1? 6. And what was the x1?
5.
Does everybody agree with DJ? Yeah, looking at your table. So then what's your y2?
And 12.
And what's your x2? And what's your y3?
18.
And what's your y3 or x3?
15.
Okay, so if I take 6 divided by 5, what do you get?
1.2.
1.2. If I take 12 divided by 10, what do I get? 1.2. If I take 18 and I divide by 15, what do I get? So is this a proportional relationship or not? Yes, because these are all equal to each other. Okay, questions over this? Now that we've kind of done some examples together.